Previously, I talked about basic global thresholding, and I explained how to find the threshold automatically. Okay, so this is the algorithm I described in the previous video. Now the question is, what if there is a good initial value for the threshold such that the algorithm converges quicker to the final threshold of the image? Okay, because here I said set initial threshold, just arbitrary. You can take any random, you can associate it with any random intensity level. Now the question is there a good or a wise value that we can use to initialize the threshold? The answer is yes, we can. So there are two main methods to initialize that threshold. The first is must be used when we have reason to believe that the object takes the same proportion of the image as the background. Okay, well, let's say that I have an image like this one, and my object is, takes a proportion or a percentage of the image that is almost equal to the background, like for example 48%, and the background would be 52%. So in that case, what we need to do is just set the threshold. In that case, the initial value of the threshold is equal to the mean of all pixels in the image. Okay, so in this case it would be directly here. Let me draw another histogram just to make it even more clear. So this is my bimodal distribution, and when the object takes the same proportion as the background, we get these surfaces almost equal. And if you calculate the mean, it would tend to the valley. Okay, it would be very close to the valley, something like this. And because our objective is to converge to the valley, this is a very good, wise initial estimate to the threshold. However, it is not in the case where the object represents a small proportion of the image, or vice versa, when the background represents a small proportion of the image. Okay, so let me explain more in detail what I'm talking about. For example, let's consider an image like this one that contains an object that is very, very small, takes just 10% of the image, and everything else is the background. Now the histogram associated with that image would be a very small peak for the object, and then a big distribution for the background, just because we have a bigger surface. Okay, and so if you take just the mean of all pixels in the image, it would not tend to the valley. It would go to a place where the density is high, something like this position. Okay, so in cases like these, what we do is just to say, well, what is the highest value? So this is the maximum value. Okay, maximum value. This is the minimum value that a pixel can take in my image, and we can say just, well, set the initial threshold as being the maximum minus the minimum, and divide everything by 2. And in this way I'm gonna get a threshold here, which is fairly close to the valley. And these are the two ways that we can use to automatically, to set the initial threshold in a way such that we converge to the final solution as fast as possible. Okay, so now this method actually fails sometimes. Okay, so it's not gonna give you a good threshold, even if the object in the background had a good contrast. So when does this method fail? Well, this method fails just exactly like in this case, when we have an object that is very small to the background, but with distributions that are close from each other, not like this case. So it may fail if we have a distribution, bimodal distribution like this one. Okay, so we can say, for example, in the beginning, the initial threshold is something like here. Okay, this is T1. And the thing is, even if you calculate the mean of this interval, it's not gonna converge to this the center of this small peak here. And the reason is because we have a very high distribution or a very high surface that belongs to the other class, which is the background. Okay, so it doesn't not matter how much you iterate the algorithm. It's not, the mean is not going to converge to this center here. Rather, it's going to converge, to someplace here, something like that. This is the mean. And in such cases, the algorithm that we discussed in the previous video fails. Otherwise, if we have objects that take an important percentage of the entire image, okay, and we have good contrast between the background and the object, then this method of global basic thresholding is very good, especially when we have high controlled environments. Okay, and what I mean by high controlled environments is a good control over illumination and also a good control over the background. So I'm going to give you an example where these global basic thresholding can be used. So let's say that I have a cookie like this one, and what I want to do is to segment it, to extract the cookie, represent it with the dark color and everything else with white color, and then I want to measure some quality parameter, like for example the size. Okay, so in this case I have a highly controlled environment, and the reason is just because I can control the lighting, like this environment I have right now. And when you have a good control over the lighting, then you can get a good contrast between your background and object. Another good control over the environment, as I said, is the background. So if I were to have a background like this, the top of this desktop, okay, so the desktop here has the same color as this cookie. So and thresholding would likely not give me the cookie I'm looking for. So the second control that I said that I have over this environment is to change the background such that the cookie and the background have a high contrast. So in this case, if such a case is possible, if such control is possible, then well, this basic global thresholding that I discussed is a good segmentation method. Otherwise, if environments are more complicated, then we may want to use some other method.